thing is when you write a website bio, you don't really expect they're actually going to read it. Because it turns out that my jokes are not as funny when I actually have to stand here and listen to them painfully. That said, okay, 3 major takeaways from this talk. First one is that every single thing we've been writing as a developer community for years leaks way too much data. Here's the issue. In this community, we've been spending decades doing things like what the last talk in here was on, right? Defending the servers against the hordes on the internet. And we forgot that our clients, like the actual people on the internet, there are some people, they're not all just Russian mobsters trying to pwn us, right? Those people are also a target, and they're a separate target. And because we've forgotten that we have to protect them as well, we started leaking too much data, and every part of our stack leaks too much data. Because of this, we can no longer blend into the crowd in any meaningful sense. We no longer have the ability where the guy in a bad action AAA movie, right, dives into a mall, they're going, holy crap, there are 20,000 people, because it's the Mall of the Americas. We're never going to find him, right? That doesn't happen. We can find them. Not like we find them, we can find them really cheaply and with stuff like this, and that will just solve the problem quite nicely. So we have to fix plots, but that's not a big deal. And then finally, we need actual fundamental and cultural change in order to fix these underlying issues. There isn't any one patch that solves any of these problems. And indeed, a lot of these problems cannot be solved by an end user and must be solved by application developers, must be solved by operating system developers, and in one case, must be solved by the IEEE. If any of you guys have ever worked with the standards process means we're never going to solve this, we're doomed. Just so we're clear. But the problem is we have to work on this, right? Because otherwise we've lost the only thing, we've lost the mandate of heaven in essence, right? The only thing we do better than our adversaries is that we protect our customers, right? As opposed to just selling them out. So if we just are just as easily selling out our customers' data as the quote unquote bad guys are, then that's it. We have no moral authority to lead anymore. Essentially, we're all just Russian mobsters working together, right? Some of us work for very nice companies and have very nice business cards, but we're not treating our clients' data with any more respect. So let's talk just very briefly about democratizing surveillance. So here's the thing. My sister hates when I say this. Direct quote from my sister a few months ago. Security is really the government's area. The rest of us should really stay out of it. This proves two things. One, that I'm a terrible brother, because, not just because I said this, but because I failed to educate my family properly. And two, that actual people with actual major degrees actually think this, right? That it's way better to just have the government be responsible for security, and they will protect us. And so it's totally okay to have NSA say, don't worry, we're going to defend your servers, because we're going to declare you a national cyber asset, right? Those of us in this room know the government can't defend anything by any other method than throwing people into prison for very large amounts of time. And they can't do that very effectively either. And yet they have a near monopoly on surveillance, right? But that's okay, because only the good guys have this surveillance technology, right? Well, crap, right? I mean, like, we have companies in Silicon Valley who are making trillions of dollars selling things like the blue coat boxes to Iran and Syria so we can do large-scale mass censorship and mass surveillance, and yet we seem unable to actually push this to a larger scale. Snowden's been really helpful for pointing out that we're doing all this mass scale, but again, hey, it's the government, right? The government has this. Well, as long as only the good guys have massive distributed surveillance technology, then there's not going to be any push to fix this, because after all, only the master hackers, right, or only the good government can do this kind of mass surveillance. So we have to fix this, and there's really only one good way to fix this type of perception, right? The idea is sunlight is the best disinfectant, right? The standard Sunlight Foundation quote. A recent study showed that cops wearing sunglass cameras were 88% less likely to commit actions resulting in complaints, and 60% less likely to use force at all. When they used force, every time a officer wearing sunglasses cameras were like right here, so you could see what he's looking at, was complained about for an illegal use of force, the officer's actions were upheld. This is not because people have been magically complaining for years and lying about the cops. This is because it turns out if we spy back on the government, then we get a lot better government all of a sudden. So this is not actually the sun. Those of you who are history buffs know this is actually the photo of the explosion of the Tsar Bomba, the largest nuclear device ever built. This is ultimately how we fix problems, right? We don't just fix problems because, like, well, we've set up a web application firewall or other kind of good, standard, hardworking, salt-of-the-earth defense. We fix vulnerabilities by making them easy to exploit until people have to do it as a primary business case. This is why Metasploit is important, and this is why CreepyDoll exists. And the problem is, like, you're a stalker. Crap. Sorry, wrong Flickr search. That was a cat. This is a stalker. As I was saying, so we do creepy work, some of us, because this is the only way we can actually make it a high priority to fix problems. So I don't hear things, which I've heard from my own law school, like, well, nobody could really exploit that, right? Only a master hacker could exploit that. Well, no. In order to make these things high enough priorities that they actually get fixed, it needs to be pointed out that every single person can exploit that. And the way to make sure that that happens is to release tools so that every single person can exploit that. I wish there was some better way. I wish that classical, responsible disclosure actually worked, but it never has, right? So let's talk about what CreepyDoll actually is. CreepyDoll is a distributed sensor network that combines wireless sniffing, distributed command and control, 3D visualization, it's a video game, guys, and grenade-style encryption to do real-time personnel tracking and true identity theft on a major urban area. This is Stalking as a web service, okay? And it's awesome, and it looks like StarCraft. One slight problem with this, how many people know about Weave or Andrew Auernheimer? Way too few. Here's the deal. The United States government has declared a holy war against security researchers, right? And this is a problem. And those of you who know know that Weave is a jerk at best, a troll, and a Semite occasionally, lots of other horrible adjectives to be applied. Here's the thing. When the United States government sends a man to 41 months in prison for accessing a public website made public by AT&T, instead of prosecuting AT&T for violation of federal data privacy laws, we have a problem and we have a bad precedent. This case is on appeal to the Third Circuit Court of Appeals, which is headquartered in Pennsylvania and also covers New Jersey, where the case was brought. And the case is pending right now. And far too few people know that this is it. This is the existential threat to security research. We don't get, in criminal law, more than one chance per generation. When we screw up once in a generation, we end up with cases that say there is no right to homosexual sodomy. And that precedent lasted from 1986 to 2003, right? We end up with cases that say that there's no right to marry outside of your race for 50 years. We end up with Dred Scott, which another 40 years, right? This is the problem with criminal law. We get one bite at an actual precedent, and if we don't win, we lose until everyone in this room dies, usually in prison. So if you haven't followed this case, I urge you to go online, look it up, go to toreckland.com, which is the website for his attorney. And also, a few of us got together and said, well, the hackers ought to do something about this, right? So we wrote an amicus brief to the Third Circuit called the Hacker Brief. And if you look at the people on this list, you have Dan Kaminsky, who's one of the 7 keepers of the DNSSEC root. You have Jericho, you have Space Rogue, you have Mudge, big deal scary hackers. You have the patron saint of the Gospel of Weird Machines, for Pete's sakes, on this list. And you should know that this touches every single person, whether you're just doing day-to-day application security for a university or for a small company, or whether you're working for a major security company, right? This issue touches everyone. And here's the United States Attorney's response. We have 2 centuries of experience divided among the 13 of us who wrote this brief. And they said, well, our arguments are without merit. We don't really understand how the internet really works. Okay, I'm just going to leave that one out there. Turns out being insulted for 3 pages is the best it ever gets when you're an amicus, right? We can talk more about why the law works in this silly way. But in the meantime, the reason I bring this up is because we cannot trust legal actions not to be prosecuted anyway. And it turns out that having your life targeted by the U.S. Attorney's Office for prosecution ruins your life for pretty much whatever's left of it. We don't test this. We can't test this. Because even though every court in the country has held that for the purposes of criminal law, Wi-Fi sniffing is absolutely legal, we can't trust that the people who test it won't be prosecuted anyway. I'll leave the next step to a braver researcher. In the meantime, I'm a law student. We have to have disclaimers on them. This is mine, nicely taken from McSweeney's. I'll just read this for a second. There we go. There, now you started to get into it. Yeah. So here's the deal. This software is all open source. A lot of it's released right now. If you take it and do something stupid with it, this is very much your problem. So let's talk briefly about DARPA Cyber Fast Track. Some of you guys might know the Cyber Fast Track programs. Mudge, a very famous hacker from way back, one of the founders of the Loft group, handed out millions of dollars to random hackers to do really cool work. This is not DARPA Cyber Fast Track work, which they make me say every single time I give a presentation on this, because they really don't like having things that are DARPA funded that start with the word creepy, because there was this problem where one of the Pentagon generals a few years ago decided we were going to be totally aware of all information. And he just started giving just straight Dr. Strangelove quotes to the press, and then now we have a PR problem. So this is not DARPA Cyber Fast Track work, but there was some DARPA CFT work that went into this, and thank you much for funding all of the hackers. So a brief roadmap I'm going to click away with. Let's talk about the goals of this project. The first one is I want to do, partially because restraints breed creativity, and partially because it's an easier case to make, all passive wireless. So the creepy doll system never wants to send a packet to a target. This gives us many things. One, it's way easier to code if all you have to do is listen, right? The second thing is that it makes it impossible for a target to detect. All of this data you're leaking, we just sit here and listen. And you never get to know that we've stolen everything from you. And it turns out we can extract a huge amount of data from just passive wireless monitoring, right? And it's more than you could get from a network trace. Because here's the cool thing. Wireless devices every few seconds scream their head off. They say, hello, I'm looking for a friend. Here is the list of all of my friends. Are you one of my friends? And you go, why yes, I am Starbucks Wi-Fi. Thank you so much for asking for me. I'll be happy to work. Anybody of you guys ever used a Wi-Fi Pineapple before? Or seen this device? It's called Jessica, it's the software that runs on it. It just means yes, ma'am. I'm one of your friends, absolutely, right? So I don't even have to do the Jessica export. I already have a list of all of your networks. There was a paper that came out about a month ago from somebody in academia, but I don't remember the university, that proved that just by taking these lists of wireless networks from the probe requests, you can get like a 75% level of identification of a correct social network, just from looking and matching shared things. They found out basically if you have 3 wireless networks in common and not all of them are variations on the theme of Starbucks, then I know who your friends are. Because it turns out if you see, well, they have the Norris Convention Center Wi-Fi, right? And they have the Delta Sky Lounge Wi-Fi. And they have, the Austin Hackerspace Wi-Fi. You guys know each other almost every time. It's awesome. So just in this little tiny bit of data, we can get a lot. And because they send this all the time, whether or not they're connected to any Wi-Fi, and even when they are, most people don't know this, but even though you're connected right now to Norris Wi-Fi, your phone is still sending a list of beacons, hoping you can find somebody higher on its list. So it continues to send all this data, which is just awesome. So how much better could we do if we didn't just have one sensor, like these sensors? I promise these are not on batteries, so they are not actually sensing right now, but just one of these little black boxes, right? I stick it underneath the table somewhere, it sits and it sniffs and it decodes and it does lots of fun things. We'll talk about exactly how it does it in a few minutes. Well, now what if I go from one of these things to 2 of these things? Or to 4 of these things? Or to 6 of these things? And I start putting them not just around the convention center here, throw a couple back over by the hotel where half the conference is staying, right? Throw a few around other places, right? Local eateries. Turns out that even if you don't do something dumb in any given single place, you're likely to do something that leaks a lot of data somewhere. And here's the cool part. Because these things have little teensy antennas inside them, basically, if I can hear you sending out your probe requests or sending out your other Wi-Fi data, I have your GPS location. Because my ears aren't very good, so if I can hear you, you're on top of me. So I get reverse GPS location all for free, and again, without ever having to do a single thing. I don't care if you run Android, iOS, or if you're a cop and therefore use BlackBerry. I still get to have all of your data. And I don't really want to know. When I say identity theft, I don't care about your social security number, right? Turns out the Russian Carter forums have that market locked up, right? I want something more concrete. I want to know enough information to blackmail you into giving me whatever I want. So those of you who live in a state capital, you can think, well, I don't need, especially if I'm willing to look for a lot of people, I don't need any particular senator to vote for my bill. I just need a senator with a moral problem. And then I get what I want. This is what it means when we say knowledge is power, right? I think that's what they meant in school. And the second thing is we want to do large-scale sensing without centralized communications. Those of you who've ever seen a takedown report from Microsoft or Mandiant or anybody on how a botnet gets torn down, you know why we don't want centralized communications. It gives the opposing side, the good guys, frankly, something to shoot at. The other thing is that even if we don't have a standard centralized communication, right? Even if it's, the command and control is distributed through a bunch of BitTorrent things, and we, upload the encryptions through the firewall because everybody lives in Die Hard 4, we still have problems. Like, for instance, you could say, well, we want centralized communications in that we want to be able to throw little 3G sticks inside these things. because that way it's easy, right? Everybody gets the phone home. Here's the thing, and this goes to my general adversary model of bad men with guns. Bad men with guns find small black box. Bad men with gun opens small black box. Bad man with gun finds Verizon 3G card with identification number printed on back. Bad man with guns goes to Verizon and says, give me account name. And then they find my name. And then we are sad, right? So we need to have a way of doing completely decentralized communications in order to prevent being tracked back by the enemy. It does make things a little bit more complicated. So let's talk a little bit now, if I can hit the right button, there we go, about just a little bit of background, a shout out to all my homies. For one thing, let's just point out that academic sensor networks are awesome and have done incredible work. This is, by the way, the MIT Computer Science Building, which is actually not in an earthquake in this photo. It's just made by Gary. But you can always tell when they're doing a sensor network paper because they always have a physical layout. So they always have a map. And their map looks like a 3-year-old was drawing a map of a magical kingdom, right? That's just the department layout. It's really cool. So academic sensor networks have done really cool research. This is where we get things like MANAs, the mobile ad hoc networks, and lots of other really great techniques we actually use, although we don't personally implement them anymore. And a lot of these people have studied some of these same problems. The difference is that each one of their sensors costs $500 to $800 a piece. And you have to program them in really, really reprehensibly hard languages like NESC, which combines all the ease and simplicity of C with all of the stability and security and performance of Node.io. I wish I was joking. So that sucks, right? First of all, I can't afford $500 a node because I'm a law student. It turns out when you leave an academic computer science program and go to an academic law program, and you go to them and say, okay, how do I get funding for my work? And they said, okay, well, what are you working on? Expecting I'm going to say the legal culture of Southeast Asia. And I go, I'm going to do identity theft. And then they go, okay, that's enough. Step away from the edge, right? So I need something really cheap. And I also need something I don't have to program in NESC, right, or any other arbitrarily hard language. I don't want to program in a PIC language. I want to be able to program on Linux, right? And the cool thing is that none of these little sensors, these great little picowatt sensors, run anything that you could point at and say, well, that's like Linux, or that's even like POSIX. So we're going to trade something, right? We're going to trade the ultimately low power of academic sensor networks for a more powerful system and for Linux. But the downside is that our runtimes are measured on AA's in terms of hours instead of weeks. So it's a trade-off. Turns out alkaline batteries are really cheap, though. Another background point, and I just found out about this just a couple months ago, is called Snoopy. So these guys from SensePost last year in the UK at 44Con took the same problem of Wi-Fi leaks too much data, and they went a completely different way with it. They did a centralized thick sensor network, and what they do is they go, Brendan is walking along, he's running an iPhone with not the newest version of iOS. Then they flip into active mode, connect to my thing, download my life, and make me cry, right? It's an awesome high sensor, just how badly can I ruin your life in 30 seconds? So go check out their work. Their work is very different, but it starts from the same purpose. One other thing, of course, is pour one out for our homies at the NSA, because it turns out that once you start dealing with terabytes of packet capture data, or hundreds of thousands of nodes sent simultaneously, that there's a lot of really hard scaling problems you have to do, right? So it's really kind of too bad that if only they'd shared their work, right? And I always said, as soon as they share their work publicly, I'll be happy to cite them. So Snowden was able to fill in the lack of academic citation for me. So now I can say, yes, the intelligence community did all this a long time ago. But they spent a lot more money doing it. So let's talk about the architecture, specifically hardware. So this is FBOM version 1. The FBOM stands for the falling or ballistically launched object that makes backdoors. The fact that I make acronyms this tortured is how you know I used to work for DARPA. So at this time, at this version, it was based on the Marvell Shiva board, which is the same thing that the Pony plugs are based on, and the Pony pads and the Pony power strips and the Pony all sorts of crazy stuff, right? So at this time, Shiva dev boards cost $99, but it turns out that you could buy, anybody remember the Pogo plug? A little run the cloud in your home thing, right? Which, because no one has ever heard of asymmetric bandwidth. So that was a company that was using a Shiva board that worked really well, and they were $150 a piece until they went massively out of business and fire-saled everything. So for like 6 months, I could actually buy this previously $150 device for $25. And all I had to do was throw away the bright pink case, because it turns out that unless I'm invading a Hello Kitty factory, that wasn't subtle, right? And the thing is, the board, even at that time, was small enough that it fits inside a carbon monoxide detector, right? One of those big honking ones from like Nighthawk. So how many of you guys have recently checked your carbon monoxide detector to make sure it is still detecting carbon monoxide, not just responding to the beep, and is not a node in my network? Nobody ever raises their hand. How many of you guys are going to go home and take a close look at all of your wide body appliances, right? Here's the thing. This board is about 3 times the size of the new board in the new FBOMs. So I can fit it in much smaller things now. This is FBOM version 2. You will notice the awesome cords coming out of FBOM version 2. It's really simple to explain what those are. So those are USB cords because Brendan can't use a ruler and forgot how big a USB plug is. This is FBOM 2.1, which has a slightly bigger case necessary to accommodate all the cords that stick out of it. So it's now based on the Raspberry Pi Model A because it's awesome. It runs Debian instead of running Arch Linux, which I just personally don't like Arch Linux. And it also runs on 5 volts instead of 12, which is really helpful. So it runs on the same USB hub you used everything else to run in. And because they run in USB, you can plug them straight into a wall. You can plug them into those cute little Minty Boost kits from Make. You can plug them into any USB battery. You can do kind of whatever you want. They're very easy to obtain 5 volts. And the total cost per node to build one of these things, if you buy them in bulk, is $57.08 for a whole sensor. And that includes 2 Wi-Fi, 2 little tiny Wi-Fi's, a little chip in the middle next to the quarter, a USB hub, a power adapter, some SD cards, and of course the Pi and a little box. So why do we have 2 Wi-Fi? Well, I mentioned before we didn't want to use Verizon or other hotspot or USB 3G devices because then you could just phone home. So how do we get internet connection? We still want to phone home, right? Or at least phone each other because we're going to be all decentralized and stuff. So it turns out the fastest way to do that in any urban area is just to connect to the local free Wi-Fi, right? Now, the cool thing is that there's a lot of these little I agree buttons you have to click on, right? Otherwise it doesn't get through. For some reason, no one had ever written a library that just clicked I agree over and over until it got internet. So now I've written that. I forgot to put the URL on this. So it's actually github.com/ussjoin/portal-smash. And it's the simplest algorithm ever. It literally looks, if there's one button on a page or one link, it clicks that. And then it checks again if it has a real internet connection. If not, it keeps clicking and it keeps following redirects. It's surprisingly hard. So we use 2 Wi-Fi because one of them is then going to be our phone home thing. We use one of them, and we'll talk about this, but it sets up a Tor hidden service, and it does all of its sensing and all of its talking upstream on one Wi-Fi. The other Wi-Fi is then free to run whatever mission you'd like to. We'll talk about one particular mission called Creepy Doll. If you don't want to build it, hey, it's fine. It's open documentation, I believe, and give you the plans away, but if you'd rather just buy one thing, especially if you're a company and you'd like to support a poor, starving law student, go to my website, you can buy them. And if you want free shipping, I have 6 of them with me, and I would really like to not bring them home. So, command and control software. Level 2, right? Now that we've gone into the hardware, let's talk about some software. This was the first of 2 DARPA Cyber Fast Track contracts. And work I originally presented at B-Size Las Vegas last year, but we've done a complete rewrite like 1.5 times since then. So let's talk briefly about how it works. Most of you guys can probably read this, but basically what happens is that inside a node, we have an instance of CouchDB. How many of you guys have worked with CouchDB before? How many of you guys have heard of CouchDB before? Thank God. Okay, just checking. So CouchDB is a document-oriented database, right? It is all of the things that Web 2.17.5 told us. Like, it's so much better than MySQL because you don't need to scale it. Yes, you do. But it doesn't have threads. Yes, it does. But it doesn't have any way to shut down. Well, that's actually true. It is a crash-only database, which is kind of cool. There's actually a reason that it's crash-only. We could talk about that offline. So we run CouchDB because it solves a lot of problems nicely for me. One of the things CouchDB also does is that it has HTTP-based replication, which is very nice. That means that any transport method can carry HTTP, we can do database replication on the fly with. Cool. So can we use SSL? Yes, we can. Awesome. Can we use client-side SSL? Now, if you look at the features list, yes, you can. So I tried this. And it turns out that no one ever tested if client-side SSL replication works. And you know that crash-only feature? Yeah, we triggered the crash-only. There's been a bug that's been outstanding for 1.5 years on the CouchDB core that says, hey, one of your flagship marquee features doesn't work at all. And they've reproduced it, and they still haven't actually figured out even how to fix it. One of the reasons is because they're working in Erlang, which is not exactly a friendly language, but hey, I swear there's a way to do client. So since that doesn't work, we use Nginx, which just acts as a client SSL certificate verifying proxy. That's all. And then we have what I call the reticle runner, which is just a Ruby script that basically downloads things from the database, checks some cryptographic values, and then runs them. And then we have the creepy doll task. We'll talk about what that does in a little bit. Reticle is now out. Thank God. Reticle took a while because, first of all, it had to be completely rewritten after the cyber fast track, and then it had to be rewritten again because Snowden told us that we can't trust RSA primes anymore, which is kind of sad making. So it all uses ECC now. Documentation is a little light, but it is online, it is ready to go. There's an image you can install on your own Raspberry Pi right now, and it's at github.com/ussjoin/reticle. So now we have a command and control framework. We have, because we're using Tor, I forgot to point this out in the slides, a way to talk to the other nodes. So what will happen is when a node wants to send a message to another node, it drops it in the CouchDB. The CouchDB nodes are all linked to each other. They all have each other's Tor hidden service addresses. So then every few seconds, it'll set up a replication. And what happens is we actually set up what I call a contagion network. It's not a peer-to-peer network because every node has to know everything that every other node does. So every few seconds, the CouchDB will connect over Tor, or the Tor hidden service protocol, so 6 layers of indirection, to every other node and push as much data as it has in, and then pull down as much data as those nodes have. This allows us to do command infiltration, because I simply send my commands, signed with some crypto stuff, into a CouchDB, and then it sends it to all of its little friends. It also lets us do very fast data exfiltration. If my data that I've stolen from your bad man with guns gets to one reticle node, then it immediately pushes it to all of the others. Even if it doesn't get to all of the others, those others will then continue the replication process. So this gives us a very fast, very robust way of doing basically database synchronization, right? Database synchronization with as many layers of indirection as possible, which is awesome, but only if you really, really want to annoy people. The other thing about this is that it's all designed as full disk encryption. Why are we doing full disk encryption? Well, so that the bad man with guns can't cold boot it. Well, if it doesn't have a keyboard, how do we do full disk encryption? This took a really long time to come up with what I have to say is kind of a silly answer, but it's cool. I call it grenade encryption. You simply stick in a USB key with a key file on it, boot the node, pull the key out, and throw it at the enemy, right? It works really well. And then the node doesn't have to have its own encryption keys, which we all know we don't do. And so the only way to attack these nodes is to do the cold boot attack, right? Here's the thing. This is an anonymous black box plugged in under a table at your workplace. Do you pull it out first, or do you just dump liquid nitrogen on it first, in case it turns out to be something important? Yeah, nobody's dumping liquid nitrogen on every random black box. If they start dumping liquid nitrogen on every black box in the room, I win, right? That's it, right? Like, hackers have won the planet, and the, air gas is now the most profitable company on the planet. So let's talk about Creepy Doll. It's a creepy doll, right? That's all there is to it, right? So Creepy Doll is designed as a distributed computation distributed system. What's this mean? This means that, well, I'm using Tor. Specifically, I'm using Tor hidden services. So those of you who used Tor before means that you know that my bandwidth is nothing, right? It takes forever to send packets. So it'd be extremely rude of me to do wireless sniffing, for instance, and then send the whole packet capture file home, right? It'll take basically an infinite amount of time. It'll never actually complete anything. So I don't have a high bandwidth channel. I have a low bandwidth channel to send data home. So therefore, I want to do as much processing as possible on any data I collect from wireless locally. I want to do it on these little boxes, right? So we're going to digest the data, we're going to throw away the PCAPs, and then we're going to ship just the digestions home. We run every query we possibly can, and we push it all the way to the edge, right? Not just because it's a new buzzword in cloud computing, but because this gives us the least possible amount of data we have to transfer home. The thing we don't do on these nodes, even though every node has the data of every other node, is we don't process multi-node computation data, right? Things that we can figure out by talking to many nodes together, we don't run locally, mostly because these things only have 700 megahertz processors in them, and eventually we run out of RAM and run out of processor, and it's really sad. So we centralize only the centralized questions. And the cool thing is that when we're going to end up with a backend, right? Because eventually we need some level of centrality because we want to have nice graphs. So we need one place that can draw the nice graphs. So what we do for a backend is very simple. We just set up another one of these things, except this is a slightly different mission. Instead of this thing scanning and adding all of your wireless devices to it and pointing out that that guy over there has a BlackBerry, so he's a cop. Instead, it just sits here and it listens to data, and as soon as it's got the data, it throws it somewhere else and then deletes it. And because, again, we're using CouchDB, deletes propagate just like every other type of information. So we have one node that just acts as a data sink. This doesn't give us centralization because all the nodes could act as a data sink, they just don't, right? So it throws it somewhere else, somewhere not connected to the rest of the network, and then we can run visualizations not against the whole network. Because those of you who ever tried to run a distributed database across like many data centers know that that takes forever to do, right? If you actually have to query all the data. So we centralize the data just for query, but not from a command and control perspective. This allows us to have all the performance benefits of centralization and none of the bad men with guns deficits of centralization. So we do 3 types of filters, which I've hilariously called NOM for reasons that are not likely to become clear at this juncture. NOM stands for nosiness, observation, and mining. And these are the 3 types of filters we run with Creepy Doll. So observation first is very simple. We're going to take as much data out of local packet capture traffic as we can. And it turns out that's a huge amount because everyone in this room sucks, me included. We leak so much data. Let's take an example of sucking. This is sucking. So what you have here is a screen cap from Wireshark from iMessage. And if you look down towards the bottom, indeed the last line, you see, aha, here is my exact hardware version, here is my software version, and my build number. This is all encoded in the user agent. Why is that in the user agent? And remember, because it's in the user agent means that it's transmitted outside of the SSL envelope, even before SSL is turned on, right? So this means that every time my iPad connects to a network, I've told every attacker exactly what to mug me for. So they can go iPad 3 one, well, that's kind of old. I want the one with the lightning connector, so I'm looking for, I think that's iPad 3 2. So heck with that, I'm not gonna mug Brendan, right? Or go, oh, but he has the new iPad 17, he's got the iPad Air, right? Like iPad 7.5, I don't even know what this user agent is. So now I know who to mug in a room, assuming I know something else about them. Well, this isn't very much data, right? Who cares, right? Well, who cares, because this isn't very much data, forgets that we're going to look for a lot of things. We're going to look over time. Two other types of filters. Nosiness filters. Nosiness filters do simple pivots on data. I mean, we tend to run these on the distributed endpoints. So they do, for instance, well, how many of you guys use a feed reader in this room? How many of you guys use a feed reader? Really? How many of you guys used to use Google Reader? Yeah, most of you. And so most of you just said, no, heck with that, I don't need news anymore, right? Okay, those of us who switched, because we're still totally addicted to RSS feeds, because they're awesome, had many different options. I'm not going to tell you which option I switched to. I will tell you that my option in the standard nosiness filter transmits, even when it's locked to HTTPS only mode, transmits my real name and my email address in clear text. So I can get that just from observation, just looking at the packet stream, not having to manipulate anything. Well, then I go, I've got an email address. So then I go to namecheck.com. Anybody know namecheck.com? Namecheck.com submits your username to over 200 websites, major websites, for got password queries to see if you have an account there. It's awesome because now I know everywhere you have an account. And I've got your real name, and I've got your email address, and maybe I can attack your email address, and all of a sudden now I own your account on every single website, right? This is very helpful. Then we finally have mining queries, and mining queries do cool stuff. Let's talk about one example. I see your device periodically at about the same time every day, in about the same place every day. The mining query goes, what is that place? Well, it's got a GPS location, so it figures out what it is. Well, that's a coffee shop. So I've now figured out, well, he goes to the coffee shop every day at 8 a.m. He always goes to the same coffee shop, right? So I get pattern and practice information. The kind of thing you used to have to pay tens of thousands of dollars to a series of private eyes who'd have to sleep in shifts and tail you around to get on just one person. Now I've gotten that because I have a small black box, right? I can do larger, fuzzier math type queries. For instance, this is device A. It wanders around. I see it all the time. It must be a mobile device because it's always beaconing wherever it goes. This is device B. I only see it in places where device A is. And what happens is device A comes to a location, then device B shows up, then stuff happens, then device B turns off, and then device A leaves. What's device B? Laptop. It's my laptop, exactly. Now I combine them. This is one user. So if you do freaky stuff on your laptop and think that you're safe because you didn't do it on your mobile device, nope. We know what your FetLife account looks like now. So now we have these 3 types of filters, and we run them in this creepy doll architecture. It's pretty simple. We've got the F-bombs we've talked about before. We throw it into a sync node, as I've already discussed. And then we run it into a backend. and we throw it out of the sync node into two backends. One is when I'm doing PCAPs, which these days I mostly don't, I throw the raw packet capture data into a Shark database, which is a huge machine learning, you can run terabytes of RAM type thing. Then I throw everything else into CouchDB, running a modification called GeoCouch, which lets me do nicely geotagged queries. Then it's served up by a Ruby server running Sinatra. It's basically just a translation shim. You could write this in any language, it's just kind of like Ruby, because I'm that web developer basically. And then we throw it into a visualization. And the visualization is very nice. Let's talk about the visualization. Well, this was its own DARPA Cyber Fast Track contract. So how many of you guys have ever wanted to be a games programmer? Come on, when you were like 10, you didn't want to make video games? Really? There we go, there's a few more hands, okay. So it turns out that games programmers know stuff. They know lots of stuff, but we don't ever talk to them, which is too bad because they know really cool stuff. So if you've ever tried to do a 3D draw on through standard OpenGL, you know that takes forever to get a single thing to show up on the screen, right? It turns out if you just buy a game engine, and Unity is actually available for free, you have a man century worth of the Mythical Man month to use, and all of the data on scaling and high performance. Here's the slight downside. Here is the actual path for my code. I write it in JavaScript. It is interpreted by C# and compiled into the .NET Common Language runtime. Then, because I'm running it on an iPad, it's actually run through Mono. Now that, boys and girls, is the debugging path for you. It works surprisingly well. I've never really figured out why it works as well as it does, mostly because these yeomen and women have spent a lot of time working on it. And the cool thing is, I can get it to run on OS X, I can get it to run on Linux, I can get it to run on the Xbox 360. And we have a nice visualization, and because we get 3D for free, and we get scaling and clustering and everything for free, we can basically spend a couple months and write StarCraft, except that instead of aliens, I have real people. So we'll watch closely, and we'll look for the creepy. Now again, we didn't collect random strangers, so all the dots you're gonna see on screen are me, wearing different hats, right? I put on my black hat, I go over here, I put on my blue hat, I go over here, I put on my red hat, I go over here. But they're all just me. We didn't collect random stranger data because the above weaves in Prism. So let's watch what happens. So powered by Unity, because why not? I'm sure they love this PR. So we'll load a gray field, and you can see the mouse moving around. So the gray field, we can move left and right. The interface is basically the same as StarCraft. You can move with keyboard or scrolling. We load data out of cloud beta underneath it. Now we have a nice GPS localized thing. And you can see we can zoom in and zoom out, kind of the 2.5D way that, say, Warcraft works. And then we can hover over different nodes, and we can do a little box zoom, just like you do to select in StarCraft, except that this will actually zoom in the area. So now you can see, well, now we just looked at one area, right? So we can see who's hanging around in the Elizabeth Link Peace Park. We can hover over them, see their MAC addresses, their GPS location. We can click on them to see all the data we found, right? And it turns out that from a dating website, I got a photo. From a feed reader, I got a name and an email address. From a weather application, I got its self-reported GPS, which allows me to calibrate my own network using someone else's data. And I know what hardware he's got, I know where he is, I know what he's doing, I know how often he goes there. And this is all because we talk too much as developers, right? This is awesome. And the thing is, it's awesome not just for random hackers. It doesn't just come out in a large table. It comes out in the 3D games interface, and it scales to hundreds of thousands of nodes, right? And we do advanced querying and advanced zooming. That's what the stuff is on the right. We can even underlay it with surveillance data. If you've found access to a couple cameras, you click that little TV button and tell it where they are, and it'll run them in by time. So it'll say, well, at 3:30, I saw Brendan walk over here. Click. Oh, that's what Brendan looks like, right? Because now we have the camera timestamp to it. It all works together very nicely. This is Creepy Doll. This is what we say when we mean identity theft as a service. There's no credit card number up there, right? I don't have to break SSL. I take a bunch of stuff we knew was leaking too much anyway, and I prove why it's bad here. So let's talk about what happens next. Well, first of all, we can use this for counter-infiltration, the aforementioned BlackBerry joke, right? There is a persistent rumor in cases of exceptional police brutality that the police usually send in an agent provocateur to throw the first rock and then magically disappear, right? And by rumor, I mean we've actually proven this in some cases through awesome FOIA disclosures. So you could just set up a device. You could say, okay, who's in this particular mob? Cool, here's all their MAC addresses. Now, if a new member joins the mob, look up their let's look at their MAC address. Maybe we set up an alarm. Maybe we just look up their thing in the IEEE database and say, oh, that's from BlackBerry. Okay, that's definitely a cop, right? Because, yeah. Or maybe we just say it's just somebody not in our group, right? So we have automated counter-infiltration, which works pretty nicely. You can also use this for OPSEC. If you're a company with okay, kind of medium ethical constraints, you can say, well, my major concern is that my employees are leaking my company data. So I want to know how much data they leak over time. So I'm going to throw a bunch of these sensors around around the campus, and maybe around the city around the campus. And I know all of my employees' MAC addresses, because bring your own device is a great idea. And so I'm just going to listen for anything they send at all. And now I know exactly how much data my company's leaking. This is an incredibly effective way. So we can use this for good and we can use it for less good. But the cool thing is that we don't need to, in order to do this kind of data exfiltration check, we don't need to control every network, right? I don't need to control every coffee shop's network in order to see this data, because they're broadcasting it over Wi-Fi for me. And the cool thing is I can see, well, why is that employee going to visit my competitor, right? Because again, they don't have to connect to a network for us to see beacon requests, right? They don't have to connect to a network for us to see where they're going, when they're doing it, and who they're with. We just have to wait for them to mess up once, and now we know their full identity. You can also use it for evidence logging, which is relatively straightforward. And the cool thing about a contagion network in an evidence logging scenario, say another Occupy Wall Street type scenario, is that if you could ship the data out one hop to just one node and it gets out of the area before you get kettled, then the data is preserved. Which again, when you have situations where people are destroying computers, let's say not maliciously, but it just seems to just happen, you can preserve data for your friends to get you out of jail, which is kind of nice if you need to know who's there. And because these things take just a couple watts apiece, you could run them on a belt-fed battery for 24, 48, or 72 hours, depending on how much weight you're willing to carry around. So finally, let's talk about scaling up. So I've run this up to 10 or 20 nodes doing sensing. I've run it up to a couple terabytes of packet capture data, but these days I mostly don't do PCAP because, again, Tor is slow. So how do we scale this? Well, once you get more than 20, 30, 40 sensors, you probably have too many people moving around the screen. Luckily, again, with the video games thing, right? You can do clustering, you can do field of view limitations, things that video games programmers have known for how long time. So that's the visualization end. Well, we can also do clustering with the way we do the networks. Because this is not a mesh network, right? This is not nodes connecting to each other. We can physically overlay creepy doll networks on the collection side without having them conflict with each other. So that is that I can just say, let's put 100 nodes in an area instead of 20 or 30. And I want them all to combine their data eventually, but they can't because they've got very little hard drives. So I don't want to have them in the same contagion group. So I just say, a third of them are red, a third of them are blue, and a third of them are yellow. They'll all just do contagion on their own with themselves. And then on the back end, each one of them will have a sync node, and it'll throw it all into the same visualization. So now, even though the contagion protocol, the gossip protocol, is pretty inefficient because you're running live simultaneous data replication to more than 20 nodes, we can keep it in very small groups to maintain efficiency, to maintain it actually happening, and yet collect from a much larger data. It turns out that once you have more than 10 or 15 nodes in a relatively small urban area, you pretty much have 100% coverage of a city, or of the core, I should say, of the city. Because you don't need moment-to-moment-to-moment tracking of every person. You just go, oh, that guy drove by. Oh, he showed up over here. Unless you need every second to know where every person is, you have more than enough coverage with just a few nodes. We're talking an investment of $500 or $600, which anybody could make by mowing lawns for a couple of weekends. If you're a kid in your basement who wants to be creepier than normal, you can pull this out, right? And finally, we can scale the back end, because it turns out that all this software runs on Amazon EC2, which provides an autoscaler. If you're submitting your illegally stolen materials to Amazon EC2, we should probably talk about how you find a lawyer now rather than later, but we can do it. And finally, this is all running Linux, and I've got a couple extra USB ports. So somebody should really add an RTL SDR to this, so we can listen to cell phone traffic, so we can listen to those little pagers you have at restaurants, we can listen to your car, so we can listen to everything. For 20 bucks, or actually $5 if you're willing to wait for a little while from China, you can get a software-defined radio that will run on a Raspberry Pi. Yes, I have tested that, and you can listen to any frequency. Obviously, you can also add Reaver to this and break into encrypted Wi-Fi. I haven't done that because there's no reason to. In any urban area, there's so much free Wi-Fi that you're going to get all the data you need. That's an obvious addition. And finally, if you want to go slightly to the Snoopy route, you could add Jassiger, right, and have nodes start directly connecting to you. So you can actually run a man-in-the-middle attack and then run SSL strip or do whatever you want, capture all their traffic and do it. I think that runs too much risk of alerting your target. This is why people don't use a lot of pineapples most of the time and for really sensitive stuff. But it's easy to add all this. So let's talk about mitigation. The problem is we have leaks at every single level, right? We have leaks from application developers. that we have to get the application developers to fix. Well, that doesn't really work very well. We have leaks at the operating system level because ordinarily when people say, well, my application leaks too much data, they say, well, use a VPN. Well, it turns out if you run iOS, you can't use a VPN. Because when you use a VPN and you connect to a new Wi-Fi network, it takes you, what, 10, 20 seconds to bring it online? And there's no way in iOS to say the VPN must go online before any of my background services like iMessage are allowed to update. It's simply not a way to do it. You can do it on a laptop, it's just really hard, but it's impossible on most mobile devices. I think Android has the same problem, no, they just don't use it. So they have to fix that. But they're gonna go, well, application developers should be better, right? And at the bottom, of course, why do we do probe requests? Well, we do probe requests because a few years ago, the IEEE said, well, hey, wouldn't it be great if your device automatically connected to Wi-Fi when you walked home? And it would be great. And so the IEEE could fix this, right? They could say, we're gonna remove probe requests. So watch how this conversation goes with the HTC. Say, hey, we've got a new wireless protocol. It's the same speed as the old one. And it's gonna be much less convenient for your customers who won't know why their device isn't connecting to home anymore until they actually click it. So your customers will hate it and you'll get no benefit from it. You wanna implement it? No. So the IEEE is actually constrained by all of its stakeholders from fixing Wi-Fi so that it doesn't leak this much data. So we are in essence doomed. But hey, it's the status quo, right? Like, it's fine. I mean, it's not like we've seen massive data breaches over the last 2 years or anything. No, the status, for those of you who like Dr. Horrible, is not quo. We have the moral responsibility to fix this, we the developers. Because again, the only thing we do that makes us not the bad guys is we protect our customers' data. And we forgot how to do that because we forgot that when we protect the data, it doesn't just mean on the servers. It means every time one of our customers walks around. There's no reason for your e-commerce application to be sending my GPS location in clear text. There's no reason for your dating application to be sending an omnipotent cookie 3 years after Fire Sheet was announced. There's no reason for any of this other than our laziness as a community. We have to do better. Thank you. We have a second for questions? We've got a minute or two. Anybody have a question? Nobody ever has? Yeah.
Did you lose any of the devices during the trial period?
No, because again, I couldn't release them anywhere. So I couldn't throw them over a whole urban area. That would have been a very bad idea. In theory, you'll lose them, but if you're paying very little per device, you don't really care. That's kind of the point. But no, I didn't lose them because I didn't leave them anywhere. Wish I could have. Anything else?
Have you done any speed tests, so put them near a highway and do you have an issue with vehicles going over? If you're trying to track people?
No, that's actually a really interesting question. Again, it goes to because I can't be sure that I wouldn't be prosecuted for testing this, I couldn't do it. That said, there are lots of tests indicating that's not a problem. For instance, the Wisconsin Department of Transportation has been doing Bluetooth throughput checks, and they just look for cars open Bluetooth identifiers and phones open Bluetooth identifiers, and then they say, okay, this many cars went through this area, and they swear that this won't be used for law enforcement purposes. So I'm sure we'll know how that works. So Bluetooth and Wi-Fi are roughly equivalent in terms of how often they beacon, and at a very low level, I should say. They're not equivalent in any other way, obviously. So it should work, except it would work better because Wi-Fi has a longer range. So I'd expect it to be fine, but I can't do that kind of testing. If you own a small city where everyone will sign a consent form and no one else will ever come in, by all means call me. Or if you're a despot from a small third world kingdom. Anything else? Thanks very much.